Hey, what's up everyone? So today we're going to do SAT Math. And our topic is recursion. Formula. Alright, so you guys must be saying, oh wait, we already did the recursion formula before. But this isn't the recursion or arithmetic recursion formula. This is the geometric recursion formula. And what I mean by that is, in this we don't have a common difference. We have a common ratio. And this common ratio plays a bigger role, actually, as to say. Because it's not always going to increase by, say, 1. It might increase by, 1, then 3, then 8, then 20. That's what a common ratio is. So, let's go on to the next slide, and I'll write out a general formula for what a geometric recursive formula is. And then we'll try and do a couple of equations from that, questions from that. So, let's get started. Alright, so the generic geometric recursion formula for sequence is a of n is equal to a of n minus 1 times r. So let's break this apart as we usually do. A of n is what we call the target. This is our target. This is what we're trying to find. A of n minus 1 is the value before the target. And r is what we've just learned is our common ratio. So this common ratio could either be something that increases it or decreases the value. So we'll look at two of those examples right now. So let's get started with a couple of examples actually. So next. Alright. So let's say we have this series 3, 15, 45, and 135. And I meant to say 5, not 3, so that's my fault, sorry. Alright, so now looking at this, let's find the common ratio between these. So the common ratio between 5 and 15 is times 3. 15 and 45 is times 3. And 45 and 135 is times 3. So let's make a recursion formula based upon what we know. So we know a of n is equal to a of n minus 1 times 3. This will help us find the next term given the previous term. So let's try something with this. Alright. So let's say we want to find a of 5. So we have a of 5 is equal to a of 5 minus 1 times 3. Let's make the font a little smaller. So a of 5 is equal to a of 4 times 3. A of 4 is 135 times 3, which is equal to 405. So that's what a geometric recursion is. And as you can see, this is a geometric recursion. And this is geometric, first of all, because there's no common difference. The difference between... Whoops, that was not good. Okay. Let's move that out of the way. Now let's look at this better. The difference between 5 and 15 is 10. The difference between 15 and 45 is 30. And the difference between 45 and 135 is 90. So clearly we have a recursion. We have a geometric series on hand. Now let's go on to the next slide and do another So let's say we have the series. Let's say we have the series 81, 27, and 9. So, I guess it's a fairly simple series, as we can see where we're going. But let's say we want to find the fourth and fifth terms. So let's first create a generic formula which will help us solve this. So we know a of n is equal to a of n minus 1 times r. In this case, r is times 1/3 times 1/3. So we can rewrite this as a of n is equal to a of n minus 1 times 1/3. So let's say we want to find the fourth term in this series. So what we'll do is we'll find a of 4 is equal to a of 3 times 1/3. A of 3 is 9 times 1/3 is equal to 3. Now let's say we want to find the fifth term in this series. So sequence, a of 5 is equal to a of 4 times 1/3, which is equal to 3 times 1/3, which is equal to 1. So this is how we use the recursion formula to find the next term given a previous term. The next video will deal with the explicit geometric formula, which will help us find any value given the first term and the common ratio. So I'll see you next video and have a great day.